Hey everyone, welcome back. If you're looking to really master the art of visual communication, well, you are in exactly the right place. Today's explainer is a pretty fascinating deep dive into the how and why of environmental design. We're going to look at how a raw, hand-drawn concept for campus navigation gets transformed systematically into a polished digital reality. We're actually exploring a real project brief from the School of Applied Arts and Crafts for their Semester 2 course, and honestly, it's a perfect masterclass in applied design.
Let's just stop and think about this for a second. Think about that invisible visual language we all rely on literally every single day. I mean, when you walk into a massive, unfamiliar university campus, or say, a sprawling hospital, how do you actually avoid getting lost? You're definitely not stopping to read long paragraphs of text on the walls, right? No, you're scanning for cues. You're looking at shapes, specific colors, and these simplified little icons that seamlessly guide you to the library, the cafeteria, or the emergency exit. So the big question is, how do designers encode all that incredibly complex information into something you just get in a fraction of a second?
Okay, let's dive into our roadmap for today. We'll start with the language of signs, move into the wayfinding mission, then tackle the vector workflow, break down the elements of visual meaning, and wrap it all up with evaluation and final output.
All right, let's kick things off with Section 1, the language of signs.
So here's the deal. You really can't design effective navigation without understanding semiotics. Basically, it's the study of how signs, symbols, colors, and even the spaces themselves communicate meaning in our everyday environments. And for the design students taking on this project, look, this isn't just some abstract academic buzzword. It's absolutely crucial. It's their core theoretical tool. It's the lens they use to observe their own campus. They've got to ask themselves, okay, what is this space trying to tell me, and where exactly is the communication breaking down? Understanding semiotics lets a designer pinpoint exactly why a certain doorway is super confusing, or why people always seem to get lost trying to find that one specific lecture hall.
Moving right along to Section 2, the wayfinding mission.
Now, the most crucial thing to grasp here is that this assignment goes way, way beyond just making something look pretty. The real goal? Solving practical, real-world design problems. These students have to actively identify communication gaps all around their campus. They need to analyze how color, form, and text actually influence human perception. And then, they have to use those highly developed observation skills to create effective navigation. Basically, they're learning how to engineer human movement through design alone. Pretty cool, right? Think about the target goal for this kind of work. Notice how successful educational symbols, things like a book, a graduation cap, or a light bulb, they instantly communicate their meaning without needing a single word of text. They're remarkably clear, incredibly simple, and highly readable. And that's exactly what this project brief demands for the final submission. It's a brilliant example of how stripping away all those unnecessary details actually amplifies the core message.
All right, let's jump straight into Section 3, the vector workflow.
Pretty much every great digital design has really humble analog beginnings. The brief states that students have to start with their hand-drawn concepts from a previous task, which were originally sketched out on an ivory sheet. These rough exploratory sketches are exactly where the raw, messy problem-solving actually happens. But obviously, in the real world of professional signage, a pencil sketch just isn't going to cut it. It has to be scalable, precise, and infinitely reproducible. So this brings us to the strict digital workflow required by the faculty. It's a very specific, step-by-step sequence. First up, students scan that hand-drawn artwork to digitize it. Then, they import that raster image straight into CorelDRAW. Now, step 3, this is the most critical part. They use the pen tool to carefully, meticulously trace the symbol, laying down those perfectly clean vector lines. Finally, they fill those crisp vector shapes with their predetermined color concepts. This is the exact industry process used to translate physical ink into mathematical, digital nodes. It's literally how the pros do it.
And the destination of all that hard work is super clear: crisp, sharp, vector-based symbols. The real beauty of a vector graphic built in CorelDRAW is that you could print it on a tiny little ID badge or blow it up to fit on the entire side of a building, and it will never ever lose its sharpness. No pixelation, no blur. They're visually consistent, totally proportional, and 100% ready for real-life application on campus walls and signposts.
Which brings us to Section 4, Elements of Visual Meaning. So, when they're tracing out those vectors, students have to heavily consider the relationship between positive and negative space. Positive space is the actual subject of the symbol, like, say, the arrow itself. Negative space, on the other hand, is the background area surrounding it.
And the brief explicitly tells students to focus on this balance. Why? Well, because if the negative space is too tight, the symbol will just blur together into a confusing blob when you look at it from 20 feet down a long hallway. Clear wayfinding absolutely depends on getting this balance exactly right.
Also, to make sure these symbols don't just look like a totally random assortment of icons, the brief lays out some strict, unifying rules. Every single symbol must be designed within a specific 4-inch by 4-inch square. They have to maintain a consistent visual style, keep equal proportions across the board, and perfectly apply their finalized color concepts. It's this strict uniformity that unconsciously tells a person wandering around the campus, yep, all of these signs belong to the exact same navigational system.
Finally, let's look at Section 5, Evaluation and Final Output.
The 10-mark evaluation criteria for this project demands total discipline. The breakdown is a perfect, even split. Understanding, concept, process, execution, and presentation are all weighted equally at 20% each. What this shows the developing designer is that a brilliant idea is basically worthless if the execution is sloppy. And on the flip side, a flawlessly executed vector file is still going to fail if the underlying concept doesn't actually solve the real-world navigation problem. It really requires total end-to-end discipline across every single phase of the project.
And then, of course, comes the physical deliverable. Because digital files are great and all, but wayfinding exists in the physical, tangible world. The brief details some incredibly vital printing specs. The final output has to be printed on a 12 by 18-inch sheet. But it's not just any standard paper. It must be 250 GSM paper with a matte finish. Now, you might be wondering, why matte? Simply because glossy finishes create nasty glare under harsh hallway lighting, which literally makes the signage unreadable. Like I said, every single detail matters here.
And look, in the design world, a deadline is a deadline, period. So here's the strict submission schedule they're working with. The comprehensive phase is due on February 17, 2026, and the absolute final submission drops on March 20, 2026. The brief also actively urges students to contact the faculty with any difficulties way before these dates hit. Because let's be real, time management is just as important a skill as mastering the pen tool.
Which brings us to our final thought for today's explainer. You now know the methodology. You've seen exactly how semiotic theory on a simple piece of paper becomes a precise, vector-based navigation system designed to effortlessly guide human behavior. So, next time you walk through a hospital, an airport, or a university campus, really look closely at the signs around you. Now that you understand this invisible visual language, how will you redesign the world around you? Keep learning, keep observing, and I'll catch you in the next explainer.